Lesson 1, Part 2. In this lesson, we will be discussing how to break a number down into its prime factors and then use those prime factors to write it as a product of exponential terms. So we are going to take a larger number and use repeated division to divide it by its prime factors to try and simplify it into an exponential term. First here, we have 125. The first thing I want to do is find the least or the smallest prime factor of 25. If you don't remember, prime factors are numbers that can only be divided by themselves and 1. So knowing your multiplication facts and being proficient in those is very useful here. So I know I'm going to use this repeated division bar that the least prime factor of 125 is 5. So I'm simply dividing here. 125 divided by 5 is 25, the next number below. Again, I'm picking its least prime factor again, which again is 5. So now I'm doing 25 divided by 5, and I get 5. 5 is a prime number. It's only divisible by 5 and 1. So our goal is to get down to that 1 and then you're finished. So now I'm going to take all of the prime factors over here and turn that into a multiplication problem. 5 times 5 times 5. Well, we know that since all three of these numbers are the same, we can make that an exponent. The base is 5, and because it's multiplied by itself 3 times, it's 5 to the third power. Now let's try here with 900, one that's a little more complicated. So again, we're going to start with 900 and divide by its least prime factor, which is 2. 900 divided by 2 is 450. Again, I'm going to divide by the least prime factor, again a 2. Now I get to 225. 225 isn't divisible by 2, but it does have a least prime factor of 3. So again, I'm going to do division. 225 divided by 3 is 75. 75 also has a least prime factor of 3. 75 divided by 3 is 25. Again, now we have a different prime factor. 5, that's okay. 25 divided by 5 is 5. And 5 is that prime factor. It can only be divided by itself. So I'm going to use all of these prime factors and write a multiplication problem. 2 times 2 times 3 times 3 times 5 times 5. Since all of these numbers are not the same, I'm not going to have one base with one exponent. But I am going to combine the prime factors that I can. This 2, these 2's here, there are 2 of them. 2 times 2, so that's where I get 2 squared. Sorry about that. Then here in blue, I'll do 2 3's, so 3 squared. And again, 5 twice. So that's where I get that 5 squared. It's simplified as much as it can be there without going back and solving it again. So the goal, like I said, is to get it all the way down to its prime factors. If you can get it down to 1, great. If not, it's still simplified. So let's try this method with 1071. 1071, that's a pretty big number. But I know that I can divide 1071 by 3 because if I add all the digits in this number up, 1 plus 0 plus 7 plus 1, that equals 9. 9 is a multiple of 3. So I know right then that 1071 is divisible by 3. That's its least prime factor. 3 times 357 is 1071. So 1071 is divisible by 3. I'm filling in all those parts for you. I'm going to put that 3 over here as well. And then 357 will go down here. 357 again is not the easiest number to think about. So I'm going to see if that same trick works, because I know it can't be divided by 2 because 7 is even. I know it can't be divided by 5 because it doesn't end in 0 or 5. So I'm going to try the 3 rule. I'm going to add 3 plus 5 plus 7. 3 plus 5 is 8. 8 plus 7 is 15. So because 15 is a multiple of 3, I know that the least prime factor, again, is 3. 357 is divisible by 3. So I'm going to do my math, and 3 times 119 is 357. $119 is another tricky number. The 1 plus 1 plus 9 equals 11. That's not a multiple of 3. So I know a 3 won't work for this one. I know a 2 won't work because this is a 9. It's not divisible by 2. A 5 won't work because it's not divisible by, or it doesn't end in a 0 or a 5. So at this point, I suggest just testing out numbers. In this case, I know that 119 is actually divisible by 7. I'm going to write it out with my prime factors that I know. 3 times 3 times 7, and it's 119 divided by 7 is 17. So now I have 17, which brings me to my bottom. 17 is a prime number. So I'm going to simplify as much as I can at this point. I only have my 3's that are doubles. So I'm going to write a base of 3 and an exponent of 2 because I have 2 of them. I only have 1 7, so I leave it there. If you wanted, you could have put an exponent of 1, but it's unnecessary. A 1 is implied if there is no exponent. And again, 17, there's only one of them, so I can just leave that as 17. Method 2, prime factorization with a factor tree, is actually the method I prefer. Whichever one you prefer is the one you should use. We're doing the exact same thing, but I just like the way this looks better. So I'm going to break down 999 into a multiplication fact. I know, since I have 3 9's here, that I can divide 999 by 3. If you can't do the math in your head, that's okay. Do some long division to find out that 999 divided by 3, 9 divided by 3 is 3. I'm just going to go through the divide, multiply, subtract, bring down. Again, 9 divided by 3 is 3. 3 times 3 is 9. Subtract. Going to get 0 and bring down that last 9. 3 goes into 9 again 3 times. I finish out my problem by doing 3 times 3 and get 9, and I'm left at 0. So 333 times 3 is 999. I personally like, when I have a prime factor, I circle it to know that I'm done on that side. And then I keep going with the other side. 333, I think it's pretty obvious here that it is divisible by 3 again. So I'll circle that one in red to show that I'm done at that point, because 3 is a prime factor. And then I know that 333 divided by 3 is 111. Again, I'm just kind of doing that in my head because I know each of these 3's divided by 3 will be 1. 111, that's that rule of 3 there. I again know I can simply divide this by 3 because 1 plus 1 plus 1 is 3. So I'm going to circle that. I don't know that off the top of my head. So I'm going to erase this division problem and do some long division again to see what 111 divided by 3 is. So 3 can't go into 1. I just put a little X there for a place marker. But 3 can go into 11 3 times. 3 times 3 is 9. 11 minus 9 is 2. I bring down my 1. 3 times 21 is, 21 divided by 3 is 7. Excuse me for my pause. 3 times 7 is 21. 21 minus 21 is 0. So here, 3 times 37 is 111. And if you didn't know, you have reached your last prime number here. So now I'm going to use all those numbers I have in my circle to turn that into the multiplication problem. So I have 3 times 3 times 3 times 37. And I want to simplify what I can. So any of those digits that I have multiple, I'm going to turn into exponents. So those 3 3s, I'm going to turn into 3 to the third power times 37. And that's it for your prime factorization lesson. I suggest you practice a couple more of the problems that are in your reteach packet if it seems a little difficult. Using a calculator on these kind of problems is okay to make the multiplication and division problem go a little quicker.